Hello students, welcome to my class. Today we will be starting a new chapter, current electricity. In your previous classes you have already studied about electricity, but that was static electricity. So we can subdivide the term electricity into two parts. One is the static electricity, another is the current electricity. So what is static electricity? When the electrons or the charges are not moving. And what is current electricity? When the charges are moving. So there is a current flow, right? In this class we will be talking about the current electricity. Now, as you know that charge on a body can be written in this form, that charge is denoted as Q, that is equal to plus minus NE. What is N? N is the number of electron or the number of electrons in deficit for the plus sign and number of electrons in excess for the minus sign. Okay, and this is a charge of 1 electron, that is minus 1.6 into 10 to the power minus 19 coulomb, right? So what is the significance of this sign? Plus sign denotes, or plus sign talks about the situation when there is a deficit in electrons, and the minus sign talks about the situation when there is an excess in electron. Now, to understand the concept of current, we have to imagine about the school situation, about our school life. When we are assembled together in our prayer line and no students are moving, so that situation, what can be seen? A lots of kids are standing together with a proper manner, right? That situation can be related to the static electricity where there is no movement. But now think about that situation that all the students are going back to their classes, so there is a flow, right? Now this is the current electricity. So what is current? Current is defined as the rate of flow of charge. So what is current? It is the rate of flow of charges. Okay, so what is a rate? Rate means a comparison with time, that in a particular time how much charges can be passed. So there is a relation with time. We can write current as charge per unit time. Okay, and again we know that Q is equal to N into E, right? Where N is the number of electron and E is the charge of electron, so we can also write current as NE by T. Now take a note that in metals the moving charges are the free electrons which constitute the current. Okay, while, put a comma and then write, while in electrolytes and ionized gases, both the positively charged ions, which is also called cations, and the negatively charged ions called anions are moving charges which constitute current. Okay, in case of an electrolyte, say N1 cations each having charge Q1 moving in one direction. So let me write first that N1 cations each having charge Q1 move in one direction. and into anions, each having charge Q2, move in another direction. So the case is quite clear to all of you, right? Okay. And each are moving in time t, so the time is t. Now what will be the current, total current? The current, write within bracket that the current in the direction of the motion of cations is equal to I is equal to N1 Q1 plus N2 Q2 by T. Okay, never forget this formula. So many numericals can come when you have to use this particular formula. Now, in the bracket, I told you to write in the direction of motion of cation. But why? To understand this particular part, we have to understand the direction of flow of current and the direction of flow of electrons. So, put a subheading that flow of current, flow of electron. I'm taking a very simple circuit. Now I am placing a battery having positive in this side and negative in this side. Okay. So the electron will be flowing from the negative side to the positive side. So this is the direction of electron flow. Electron flow. Okay. It is also called electronic current. I think this term is quite familiar to you as you have already read it in your class 9. Direction of electron flow are from the negative side to the positive side. It is also called the electronic current. And the conventional current flow, this is the conventional current flow. It is always happening from the positive side to the negative side. From the positive side to the negative side. So, current is nothing but the conventional current. Okay. So, this flow is from the positive side to the negative side. And direction of electron or the flow of electron is from negative side to positive side. Is it clear? If it is not clear, let me know. Now we will be talking about potential and potential difference. What is potential? See, in common English, we usually say that she has a potential to sing very nicely. So it's talking about the talent, right? But in case of electricity, it is defined in terms of work done. Suppose I have to place a charge in this plate. This is a bowl. This is not a plate, by the way. So in this particular bowl, I have to put a charge. And this test charge means nothing but a charge with a very small value, and it is considered that its presence does not disturb the charges already present in that region. Okay, so this I have to bring this test charge from infinity from infinity to this particular point. So I have to do some work naturally. Now this is the work. So write it down in your copy that potential at a point is defined as the amount of work done. I'm repeating. Potential at a point is defined as the amount of work done per unit charge. Per unit charge in bringing a positive test charge from infinity to a particular point. To a particular point. Okay, and its symbol is V. Symbol is V, and it is a scalar quantity. The quantities which we have studied today, that charge, current, potential, these are all the scalar quantities. Okay, so it has magnitude, but it does not have any direction. Now what is the, okay, coming to the part of units, I'm deviating you a little bit and writing all the units. So the physical quantity is I unit. Okay, first is charge, and I'm making another column for symbol. Many of you, I have noticed that you are confused about what is symbol and what is SI unit. Symbol means it is not possible for all of us to continuously write a particular word again and again and again, right? So symbol is nothing but a presentation, a representation of a word. Okay, suppose if the name of a teacher is Niharika Varjariya, we can say NB ma'am, right? Symbol is like that only. So charge is symbolized as Q, but its SI unit is Coulomb, COULOMB, and the symbol of Coulomb is capital C. Are you feeling confused? Let me know by writing in the comment section, or my students can also directly ask me over WhatsApp. Okay, next is the current. Current is symbolized as I, and its SI unit is ampere. Symbol is A, capital A. Next, potential. It's a good to remember that its volt, its symbol is V, and its unit is volt. Okay, and as you know that V equal to work done per unit charge, right? So potential is work done per unit charge. So that means W by Q, right? So potential equal to W by Q. If I follow how to derive a unit from a physical quantity, I think all my students know it very well. So the SI unit of work done is joule, and charge is coulomb. So SI unit of potential is joule per coulomb, and another name of joule per coulomb is volt. So 1 volt is equal to 1 joule per coulomb. Is it clear? I think it is clear. Now getting back to our main point, now we will be studying about potential difference. It's very easy. Write it down in your copy that potential difference between 2 points is equal to the work done per unit charge in moving a positive test charge from one point to other. So in case of potential, for understanding purpose, we can think about that I have to bring a test charge for that matter from infinity to a particular point. But in case of potential difference, we are discussing or we are playing just in 2 points. We are concentrating our focus on just particular in these 2 points. I have to carry a positive test charge from this point to that point, and that is the potential difference. Okay, so if the point is A, this point is B, so the potential at this point is VA, potential at this point is VB, so VA minus VB is W by Q. Same as that of potential.